Hi, Jasmina. Hi, everyone. Thank you so much for joining us today in this webinar. My name is Diego Zamboni. I work at CFEngine, and I'm the author of the O'Reilly book, Learning CFEngine 3. The purpose of today's webinar is to give you an introduction to CFEngine, to show you some of the things that it can do, and also for those who have encountered CFEngine before, to give you an idea of what has changed in recent times with CFEngine, because there's been a lot of activity and a lot of things have changed. So let's get started. First of all, what is CFEngine? And this is a question that can be answered at several different levels. Up front, we could say that CFEngine is an automation tool that allows us to automate system administration tasks. However, by these criteria, shell script is also an automation tool, and it's a very primitive tool at that for the purposes that we're talking about. So we like to think of CFEngine in grander terms. So we say that it's a configuration management tool. Now we're going to a higher level in which we are now expressing desired configuration states for a system and for some of its components. However, we like to go even higher level, and we say that CFEngine is a framework for managing IT infrastructure using knowledge. The ultimate goal for CFEngine is to be a tool that can both express and capture knowledge about the infrastructure that is being managed, so that high-level decisions can be taken with the certainty that the low-level details are being taken care of automatically by the framework. And this all comes in the context of a way of thinking that we have for systems. And let me tell you a little bit about this. This comes in the form of what we call the three waves of IT. And this is taken from the work of a sociologist and futurist called Alvin Toffler. He wrote a book called The Third Wave and some other books. He has this concept of human society evolving in three different waves. The first wave was the agricultural society, in which things are done by hand and people are mostly self-sufficient. The second wave is the industrial age, the industrial revolution of big corporations, production lines, and large-scale standardization and automation of some things. And the third wave is the wave of knowledge, the age of knowledge in which we live now, largely, where we're used to having things customized for us. We are used to having the knowledge that we need at our fingertips, and we are used to having the tools that we want for obtaining the information and the goods that we need. We map these waves onto the field of IT management. And the first wave is what I call the ad hoc wave, which is the state in which system administration was up until a few years ago. And I call this also the age of the heroic sysadmin. So this was the state in which systems were largely managed by hand. Sysadmins did have automation tools, but they were mostly built ad hoc for each particular environment. There were systems that produce alarms, but again, they were specific for each environment. Systems were managed largely individually, and any response that had to be taken to any sort of anomalous condition had to be done manually. And this, of course, results in systems that are very hard to scale, and also sysadmins that are very hard to scale. A single person cannot handle more than a few dozen systems if he's doing everything by hand. So this is hard to keep up with. Next comes the age of what I call the mega machines, and I'm thinking here in terms of large IT organizations, big outsourcing companies like the HPs and the IBMs of the world that do IT management in very large scale. This is the age of extreme specialization, what I like to call the production line sysadmin, in analogy to the production line in a factory. So if we have a production line that is making cars, then we have a bunch of people that each one of them are doing a specific task. They're assembling a particular piece, but they may have very little idea of what the end product will look like. And this is the way that large-scale IT management still works to this day to a large degree. So we have, for example, teams in which there is one person in charge of installing the operating system, and there's another person that is in charge of configuring storage, and another person that is in charge of configuring backups, and so on and so forth. So to install a single machine, we need a team of 20 to 30 people, which is very cost-effective for the organization because each person needs to be trained only in a very specific set of tasks. But it's very inconvenient for solving problems and for learning what the higher purpose of the system is. So we have extreme specialization, we have standardization, we have systems that have to look always the same because this is the way that things work. And one of the more damaging aspects of this, in my opinion, is that this contributes to a lack of personal responsibility from the part of the system administrators. If in a production line chain like this, something fails, it's very hard for anyone to be willing to take responsibility or to be willing to step up to try and fix the problem because everyone just did their own part and no one feels responsible for the end product. So this is a very bad thing. Another big concept in the second wave of IT management is that of rollout and rollback. And you may be familiar with this concept of time windows during which changes can be made to a system. And the idea is that if anything fails during this time window, then we will roll the system back to its original state and start over again. The analogy here is to launching a rocket into space. This is a very expensive operation, very complex, that is planned for months or years in advance. If something happens during the launch of a rocket, well, if we are lucky, we go back to the countdown and to the drawing board and try to plan a new launch window. If we're unlucky, we pick up the pieces of the rocket and go back to the drawing board and try to build a new thing from scratch. This is very different from flying a plane in which you are able to take off roughly in the direction in which you're going and then course correct along the way to eventually get to your destination. And this is the way of thinking that we're trying to promote. And this takes us to the third wave of IT management, which is the age of knowledge. And this is the age in which system administrators or infrastructure engineers, as we like to call them, have a higher level knowledge about the infrastructure. They have the tools that they need to have instant and very comprehensive information about what is going on in the infrastructure, and also to affect the behavior of this infrastructure according to the needs. This is the age in which users are expect to have a very customized, personalized experience according to what they need. They're not willing to settle for cookie-cutter approaches anymore. So the infrastructure needs to be much more dynamic. We need to be able to make changes very quickly, to make instant customizations or modifications to the systems according both to user preferences and also to behavior of the system. So if suddenly the demand for a certain resource increases tenfold, we need to be able to adjust the capacity, for example, dynamically in response to this. It also comes with the diversification of the system administration population. So these days, you may have heard of the DevOps culture, so to speak, in which a lot of people who were originally trained as developers now have responsibilities over the management of systems, or have the need to do so to make the entire deployment cycle much more agile than it used to be. So we have now people who are in charge of managing IT infrastructure that do not have the classical sysadmin training, but still they need to perform their tasks and to do them in a useful fashion. So they need even more powerful tools to be able to automate and manage the complexity of these tasks for themselves. So let me give you a few more examples of second wave versus third wave thinking. Some of the concepts are, for example, the concept of a gold image that used to be this master image from which all the systems in an organization are installed. This is useful because we can easily replicate the configuration of the system many times, but then making any sort of changes is very hard. If I want to add a software package or change the configuration of the system in any way, well, I have to redo the image from scratch and start installing it all over the place. In the third wave, we think of this as, let's just do a regular installation of the base software and then customize it to what we need. So in this case, the end result is the same, but if we want to make any changes to the systems, we can just change that particular piece of configuration, and we do not have to start from scratch again. There's also the concept of package level management, which means not only software packages, but also packages of services or behavior or configuration that are bundled together and that are installed or uninstalled as a single unit. And this is the base unit of management in second wave thinking, whereas in the third wave, we like to have the ability to do surgical changes and to only fix what breaks in a system instead of having to reinstall things. There's the concept of change windows and rollback, which I already talked about, and we replace that with continuous monitoring and correction of the behavior of the system. Now, these concepts of gold images, package level management, having to reinstall to fix things results in very infrequent changes because it's a very heavyweight process of making any sort of changes. And this just doesn't go with today's infrastructure by far anymore. So we like to think in much more agile terms in the third wave IT management. And finally, some of the systems that evolve during the second wave are very heavyweight. So large-scale configuration management and provisioning and deployment systems that are so complex that we end up with a need to manage this system, and we need a team of people just to manage the management system, which is very inefficient. So we would like to have tools that are largely self-sufficient, self-managed, self-healing, and mostly that are very lightweight, almost transparent when they're in use. So, of course, this is all leading towards CFEngine, and I'd like to tell you about why CFEngine is unique in this respect. First, CFEngine is designed to manage the entire life cycle of a system, not just the initial installation or the rollout, but to actually go with the system throughout its maintenance and updates and all the phases of its life cycle. It's meant to be largely self-sufficient once it's set up, and also to be able to do incremental deployment and correction of the systems, and also of itself. It's very lightweight. It's written completely in C, so it runs essentially anywhere. We have proof of concepts of CFEngine running on everything from Android devices, embedded storage appliances, network devices, and of course on all sorts of computing systems. It's very flexible and very versatile in the sense that CFEngine makes very few assumptions about the underlying system. It doesn't have any hard-coded knowledge about the underlying system, so it's able to operate on top of almost anything. And perhaps the most profound difference of CFEngine is that it's not something that has evolved organically over time, although that has also happened, but mostly it's based in an underlying theory called promise theory that describes its behavior and allows us to predict what CFEngine will do under a particular circumstance when it's managing a system. So its features, its components are all based on this underlying theory to ensure that it has all the appropriate capabilities and all the appropriate behaviors to end up in a consistent and repeatable state for a system. So all of this is very nice, but what does it look like? So CFEngine 3 is a completely new language from CFEngine 2, which many people have encountered. So CFEngine 3 has a new syntax. It's a completely different language. It has a very consistent and repeatable syntax. And this is what it looks like. At the top, we have, in this example, a services promise. And services promises in CFEngine allows us to manage system services. So let's say I want to enable SSH on a system. This is essentially what I have to do. I just tell it that I want to enable the SSHD service. I can specify a comment that tells me what the intent of this particular promise is, although it's fairly obvious in this case. And that's it. CFEngine, through its existing standard library, knows that how to handle the SSH service on different platforms, depending on which particular operating system it is running on. And the default behavior for a services promise is to enable the service. So this is all I need to do. Now, if I want to make sure that SSH is not running, then I just need to tell it, like in the bottom half of the slide, that I want the service to be stopped. So the service policy attribute of this promise is to stop the service. And of course, I also can specify a comment that tells me the intent of this particular promise. So let me explain you a little bit. In CFEngine, everything is a promise. So we have a promiser that is the object or the object that is being affected by this promise. And then a promise can have attributes. In this case, comment is the name of an attribute. Service policy is the name of an attribute. And the promiser is a string that tells me the name of the service that is going to be affected, in this case, started or stopped in the system. One thing to notice here is that the comment on each promise is part of the language. So it's not a syntactical construct that, like with a hash bang, that you can add comments in most languages. It's actually part of the language, and as such, it is accessible from the tool, because large part of the purpose of CFEngine is to be able to document how a system will behave. And having the intent of each promise documented in the language itself allows us to have this information available, which makes, for example, log files much easier to read by a human when we are trying to determine what's going on in the system. Now, of course, this is fine, but at some point we have to give CFEngine a bit more detail about what we want to do. So let's go down one level. So we have enabled the service. Now we want to be able to configure this service. So this next slide shows an example of CFEngine code that can be used to configure SSH. And it's, again, fairly easy to follow. So we have a section with variable declarations at the top, in which we are setting the values that we want for each one of the SSH parameters that we want to configure. And then in the next section, in the files promises section, we are telling CFEngine that we want to edit the etc ssh sshd config file. In this case, that file is the promiser. We're giving it a handle, which is just a name for this promise. We're specifying a comment that, again, says it's going to set the SSH configuration to a certain value. And then the meat of this particular code is the edit line attribute that tells CFEngine that I want to set the config values on this file, on the file that is the promiser, according to the values stored in the SSHD array that I defined in the variable section. Now, this bundle knows internally how to set these values, and I don't have to worry about this. Now, if CFEngine makes any changes to this to the file, then it considers this promise to have been repaired because it had to do something to bring it to the desired state. So we have the classes attribute that tells me if this promise was repaired, then I want to set this class. A class in CFEngine is a Boolean attribute that with an arbitrary name that tells me whether some condition is occurring or not. So we're setting the restart SSHD class, and in the last section of this bundle, we have a commands promise that says if the restart SSHD class is set, then I want to execute the command to reload the service so that the changes I made are taken into account immediately. So this is where I want to mention something that is very central to CFEngine, which is the concept of convergent configuration. CFEngine does not guarantee that the entire system will be in the desired state after the first run, but it will keep converging the system towards the desired state. So maybe on the first run it changes the configuration file, but it is unable to restart the service for any reason. Then the next time, CFEngine will notice that the configuration file is already in the desired state, so it will not make any other changes, but it will notice that the service has not been restarted, and then it will try to do that, so that eventually the system will converge to the desired state. And this is something that is central to CFEngine, and in particular to CFEngine 3, is the ability to operate at many different levels. So let me give you an example. So at a certain level, CFEngine knows how to manipulate strings. So for example, how to split a string into space-separated values and how to set the values of the different parts of a string. This is very basic string manipulation capability. Now, using this capability, we can build a bundle. A bundle in CFEngine is a collection of promises that knows how to interpret and modify lines of the form parameter space value. And this can be applied to many different types of lines or files. Now, using this capability, we can encapsulate it into another bundle that allows us to set the lines in a file according to this format. And we can then use this capability to edit SSHD config, like in the example that I showed you before, which is built on top of other bundles that know how to do this type of manipulations. Now, we can group this bundle with others, for example, one that edits the SSH config file in addition to SSHD config, into a bundle that knows how to edit the file for an entire subsystem, for example, SSH. And once we have this component, we can group it with other components that do other tasks like installing the SSH package or enable the SSH service that allow me to configure SSH in its entirety in a single system. Once I have this bundle, and I can at each level I can abstract away the lower levels, so I can just use them as components that I don't have to worry about their implementation. I can then group this with other similar bundles for other components such as Apache or PHP or basic system configuration or anything else I want to install an entire web server with all the components that it needs, install and configure all the different components needed to deploy a web server. And once I have this bundle, then I can replicate it many times to install and configure as many web servers as I want. And then I can get me a cluster of web servers. And once I have this capability, I can group it with other similar bundles, for example, for installing database servers or DNS servers or NTP servers or any sort of machine, and then install and configure an entire data center using these components. And once I have abstracted this capability, I can replicate it as many times as I want to instantiate as many data centers as I want in the world. So this is, of course, a very generic example. It's very high level, and it's ideal in the sense that to actually do all of this, of course, takes a lot of planning and work, and it's not as simple as drawing a picture. But that's the goal that we have with CFEngine, that each level can be abstracted away, and you can reuse these components to instantiate more complex components on top of them, and then reuse these capabilities without having to worry about their actual implementation underneath. So this is at a very high level. Now let me get onto more practical details about CFEngine. The current version of CFEngine is version 3.3.3, which was released just last week. And we have a commercial, this is the open source version of CFEngine, and we have a commercial version based on the open source version that adds some additional capabilities that I will mention a bit later, that was released yesterday. So it's very fresh. The new releases are really nice. They have some nice capabilities. Not too long ago, we moved all of the CFEngine community code to GitHub, so it's much more easily accessible, and it's easier to look at what's going on, and of course even to make and contribute to code if you want. We have a new initiative called the CFEngine Design Center that launched just yesterday, and that I will mention in more detail in a second. We have a new website that came with a new release. We've been promoting a lot of community activity, so we have a lot of new resources and a lot of new things that are going on in the community. And of course, we have the book that came out not too long ago that is meant to be an introduction to CFEngine for people who would like to use it to manage computing systems. So in CFEngine 3.3.3, there's a bunch of new features. Some of these appeared since 3.3.0, and they've been improved. Now, I apologize for the strange characters in this slide. They were supposed to be names of the actual promise types, but they came out strange. So we have a new promise types for service management. It's called the services promises that allow us to manage services on Unix and Windows systems. We have a new template engine that allows very powerful and very flexible editing of files, and it's called an edit template attribute to the files editing promises. We have new capabilities for database and virtual machine management. These are database promises and guest environments promises that allows us to instantiate and configure database tables, for example, or virtual machines under different platforms. We have several new functions, for example, like for mapping values from doing value transformation in lists, for some other convenience functions for file and directory manipulations and things like this. And there's a lot of bug fixes and performance improvements as well. So let me tell you a bit more about the move to GitHub. The name of the account is CFEngine, and the repository core contains the code of the community edition of CFEngine. So you can watch development as it happens, and of course you can have access to the code as you wish. There's the CFEngine Design Center. So one of the complaints that we've had with CFEngine over time is that it has a high initial learning curve, and there's been a lack of shared resources and shared policies in CFEngine. So we've built the Design Center as a repository of shared components that we call sketches. And we have a tool called CF Sketch that allows you to install and find and configure and use these sketches. So it makes it very easy to get started with CFEngine by performing actual useful functions without having to be an expert in the CFEngine language. So these are components that are ready to use. You can just download them, specify the parameters that for that particular sketch, and then just enable it, and it will do its thing without you having to touch the code. The Design Center also hosts general examples of CFEngine policies that you can use to look at them and to get started to learn perhaps some more advanced techniques. And it also hosts several tools that you can use to make your life a bit easier with CFEngine, including editing modes for Emacs, for VI, some tools to analyze CFEngine policies. The CF Sketch tool itself is hosted there, and some other things. So I encourage you to take a look. It's classified by categories. So, for example, here we're looking at a sketch called tzconfig that allows us to configure the time zone in a system. So each sketch has one particular task that it does. So it's very easy to know what's going to happen when you enable it. We have a redesigned CFEngine website. Actually, now it looks the visual aspect is a bit different if you look at it right now, because there was a new version released yesterday. But we've been working not only on the visuals but also on the structure of the website to make it much easier to find useful information, particularly for community users. So we have a community page that has pointers to all the different resources that we have, including the forums, the mailing list, different external websites where people have information and policy examples and other things. All the documentation about CFEngine has been reorganized into topic areas, so it's much easier to find. If, for example, if you're interested in security, you can just look at the security area and find all the documents that will be useful in this respect. And we also have a comprehensive listing of all the CFEngine manuals and guides that you can look at, and this way it's easier to find if you know what you're looking for already. There's one of the characteristics of CFEngine is that it has a lot of documentation. There's a lot of guides for different topics, for different tasks, for different angles of managing systems and looking at the system. And it's very extensive and very deep documentation. So there's a lot of information out there. Of course, in terms of community, we have the website that I already mentioned. We have the CFEngine forums that are a very friendly place for asking questions, for getting feedback, for looking at what others are doing. We have an IRC channel on Freenode that was kind of dormant for a very long time, but it's become much more active in recent times. And in both the forums and the IRC channels, you can usually find not only users of CFEngine, but most of our developers and engineers also frequent these places. So it's a good thing for getting direct information or asking questions directly from the source. And of course, the Design Center that I already described, which is a great resource not only for the components that you can download and use, but also as a source of inspiration and learning, just by looking at the code and learning how to do different tasks with CFEngine. There is, of course, also the CFEngine book that came out not too long ago, and that is a great resource for learning CFEngine if you're starting from scratch, and also for learning some more advanced techniques if you already know CFEngine. I would like to mention also very shortly the commercial edition of CFEngine, which is built on top of the community edition. So if you start by learning from the community edition, you can directly transfer your knowledge to the commercial edition, but it includes more features for managing very large-scale systems. And mostly it has vastly improved capabilities for monitoring what's happening with the infrastructure. With the CFEngine community, you write your policies, you deploy them, and you can be sure that CFEngine will be managing the systems. But it is not as easy to get a comprehensive picture of how the different systems are behaving, particularly in very large infrastructures. With the CFEngine Enterprise, you have very powerful tools for reporting, for looking at graphs, for producing summarized reports of the behavior of the systems. It's very easy to query the hosts, even across very large infrastructures, to see the precise state in which each host is at a moment. You can group them by arbitrary criteria, which is very nice and a very useful tool for iteratively improving policies, for example, or for iteratively changing the systems in different ways and then seeing how they react to these changes. So this is actually all that I had at the moment. I think it went a bit faster than I had planned, but I would I would love to answer any questions now. I can see that there are a few questions already in the Q&A panel, so let me go over them. Let me go at them in the order in which they were posted. Does CFEngine work in mixed Linux and Windows environments? The answer is yes. CFEngine community supports only Unix-like environments. The enterprise version has native support for Windows, so it has you get a Windows installer, and it's not simply because it's a compiled product. It's not written in a scripting language. It's actually compiled natively under Windows, so it has very good performance, and it knows how to handle many native Windows features. So enterprise knows how to handle Windows services. It knows how to inspect and manipulate the registry. It knows how to install Windows MSI packages, Windows users, and some other things. And it integrates nicely in a mixed environment because everything is reported back to the policy hub. And you can see across the entire infrastructure the behavior of both Linux, Windows, Solaris, AIX, HPUX, any of the platforms that you have and that we support are concentrated in a single place. So it's very, very easy to keep track and to observe what's going on. How much the lack of a good introduction to CFEngine has impaired its adoption? Was it a communication problem, a documentation problem, or what else, in your opinion? I think it's been a bit of both. So CFEngine, as you know, has a very long history. The first version of CFEngine appeared in 1993, so it has almost 20 years now of evolution. For a long time, CFEngine was entirely an open source project, and in fact, it has very wide adoption. We don't have exact numbers on how many machines out there are being managed by CFEngine 2 because for the longest time, this information was not something that we kept track of. But we have anecdotal evidence that indicates there are millions of machines out there in large data centers and large organizations that are managed by CFEngine 2. And they're mostly invisible because people they know it just works and they just keep on using it. For CFEngine 3, which came out in conjunction with the CFEngine company that now backs up the commercial version, we've seen a large growth, but it is true that the documentation was perhaps not so well organized for a while, and CFEngine incorrectly has this image with many people that it's an old tool and it's outdated and it's not something that you should spend much time on. Unfortunately, because CFEngine 3 is a very new tool, it's a very fresh implementation, and it's actually very nice and very different from previous versions of CFEngine. So I think there's been a bit of an image problem, but that's precisely what we're trying to change with events like this and with the publication of the book and some other things. Can you compare and contrast CFEngine with the other major players in the space, Chef, Puppet, Control Tier, and Salt, not only in terms of the tool itself, but also the community, commercial support, and documentation? Let me talk about Chef and Puppet, which are the two that I'm most familiar with. In terms of the tool itself, CFEngine is much lighter than Chef or Puppet just because of the fact that it's written in a compiled language and not in Ruby. So it has much fewer dependencies. You don't need to install almost any additional libraries or tools or languages or anything like this to have CFEngine installed. For this same reason, CFEngine is able to run in a much larger variety of systems. So as I mentioned earlier, we have CFEngine running on Android devices or on routers. One of my colleagues has CFEngine running on the Linux-based router that he has at home, and he uses it to configure the router. So it's much more flexible in this respect. So the CFEngine is able to run with a 5-minute update interval by default, which makes it very easy to make frequent changes to the infrastructure, and also for CFEngine to react much faster when something fails or when there is a problem. In terms of community, I think Chef and Puppet have amassed a very large user community. So, for example, the Chef cookbooks repository is very large by now. Chef is a very nice tool. They have a very nice user community. And they've become very active and very popular in the DevOps community, partly because they're implemented in Ruby, and a lot of people are familiar with the language already, so they feel more comfortable in this writing things in Ruby than learning a new language like CFEngine. But the CFEngine community has also grown a lot in recent times, and we're trying to reach out much more to the community for feedback and to have a better communication with the user community. In terms of commercial support, I think the 3 products are similar. So Chef and Puppet also have commercial editions of the products, and they all 3 function on similar ideas. So they are all a subscription service, something that you pay regularly for in order to get support, in order to get access to different resources. In terms of documentation, I would have to say that CFEngine is far superior to Chef and Puppet because the documentation is really extensive. In fact, CFEngine has been accused of having too much documentation, and sometimes it's hard to know where to start, which is something that we've tried to address in the recent reorganization that we did of all the documentation. If you look at the CFEngine guides, they are very detailed. Almost all of them have concrete examples that you can try for the different features or for the different tasks that you can perform. We have guides on everything from orchestration, security, change management, ITIL compliance using CFEngine, teamwork. How do you coordinate a team of sysadmins that are using CFEngine so that they can all make the changes they want without conflicting with each other? All sorts of things. In addition, of course, to the basic documentation, the basic language documentation, basic tutorials, guides, and all of these things. So the CFEngine has a really strong set of documentation. And going to the next question, are more advanced CFEngine webcasts coming in the near future? Well, I guess that largely depends on you and on the feedback that you provide in response to this particular webcast. I would be happy to do much more concrete, specialized webcasts on more advanced topics. And this is, I think, something that could definitely be coordinated if there's enough interest for it. So these are all the questions that I had here in the panel.
Actually, Diego, hi, this is Yaz here, your host. If you click that refresh button right above it, I don't know if you can see that, we do have a few more questions that have come in.
Okay.
And folks, we just want to let you know, while Diego is still with us, please send in your questions so we can have him answer that while he's with us. Back to you, Diego.
Thank you, yes. Well, I am clicking the refresh button, and I still see, here, I got them now. Excellent. So why did you choose to implement CFEngine in C? It seems like most tools like this are written in Python, Perl, Ruby, etc. Well, this has both historical and practical reasons. First, CFEngine was initially born in 1993, where there was no Python, there was no Ruby. I don't think even Perl was around in those days. Maybe it was, but in very early release, in a very early version. So back then, it was either shell script or C, and C was the much more efficient alternative. Now, as time progressed, there was evidence that C was a good choice because it was able to run very efficiently on most systems, even on low-end systems. CFEngine can run without any problem. And these days, with the explosion in types of devices that we have, well, being written in C makes it possible for CFEngine to run on an Android device as well as on a supercomputer or on a desktop or on a server or anywhere. I'm always telling people that our not so secret aspiration for CFEngine is to have it running on the space station. So hopefully that will happen at some point in the future. Next question. Does CFEngine maintain a revision history of changes, dates, user making the change, etc., and can this be easily replicated for business continuity management purposes, or should these scripts be stored in a repository for revisioning? This is an excellent question, and it's one with a fairly complex answer because there's more than one single way of doing this. First, CFEngine, as it makes changes to the systems, it can keep copies. For example, when it's making changes to files in the system, it can keep an infinite number of copies of the files with timestamps so that you can go back to any point in time. That's one way of looking at it. CFEngine can also keep a log of all the actions that it takes, so this can be examined to see what happened when. But mostly, CFEngine is meant to be, a CFEngine policy is meant to be a documentation of the state in which the system has to be at that point in time. So if you have a version control repository and you keep your CFEngine policy files in that repository, then you check in new versions as you update the policies, and each update of the policy will be reflected in changes in the configuration of a system. Now, if at any point in time you need to reconstruct the system, ideally you deploy the CFEngine policy and it will configure the system according to the specifications in that particular point in time. Now, of course, in practice, things are much more complex because you also would have to worry about the data that was stored in the system. And maybe not every single aspect of a system is managed by CFEngine in a practical implementation. So there's more than one component that is to be tracked. But in principle, the CFEngine policy is the ultimate authoritative resource and reference for the state of a system. And in the CFEngine Enterprise version, there's also a facility for a workflow in which each new revision of the policies can be subject to authorization. And only when someone with the appropriate authority has said, okay, this policy is correct, then it will be put into production, and you can see a record of who authorized what when in changes to the policy. Puppet user here many times have difficulty separating code and configuration. Any general rule of thumb for this separation? Let me think about this for a moment. I think this is a common problem with these types of tools. Particularly as you start expressing the desired configuration of a system in a policy file, it becomes very easy to embed data about that particular system in the file itself, and then you start mixing, as you said, code and configuration information. I would say my general rule of thumb when writing CFEngine policy is that anything that is system specific or operating system specific should go either in a configuration file or in a library somewhere where we can have this distinction. At the top level, we should have only the high level desired state of what the system should look like. So let's say my top level policy says I want a web server. Now, I don't know how a web server is implemented, but that's the goal to which I'm aspiring. Now, as we go down in the abstraction layers, I can say, okay, a web server needs Apache, needs PHP, and needs some other things. Now, as we go down, I say, okay, Apache can be installed in a Linux machine, can be installed with a package. In a Solaris machine, maybe it needs to be compiled from source. In a Windows machine, it needs to be installed in some other way, and so on and so forth. And as we go down to the more detailed levels, we start making the distinctions between, okay, now if I'm installing a package on Debian, then it's different than Red Hat, and it's different than Gentoo, and it's different than any other version of Linux. And we start having this implementation distinctions between how things are actually done. So my general advice is the higher level that we're looking at things, the less details there has to be, and the more generic the statement has to be. And as we go down, we want to have more implementation level details. And if at all possible, instance-specific details, like, for example, an IP address or the name of a cluster or things like this, those should be completely separate into a configuration file or a particular site-specific or host-specific specification. Let me see if there are any more questions here. How easy would it be to take configuration changes made to a set of servers and then merge or replicate that to another set after the set has moved to production? In CFEngine, this is supposed to be fairly easy because you have the policy that details what changes have been made to the system. So you can, in an ideal situation, you install, for example, Red Hat Linux on a server, and then everything that happens after that initial installation is handled by CFEngine, from network configuration, storage configuration, user configuration, any sort of package management, everything. So once you have this policy well developed and it's working, then you can replicate this as many times as you want just by deploying the same policy in every single host where you want to replicate it. CFEngine also makes it fairly easy to have this concept of different production environments. So you can have, because you can with CFEngine you can differentiate, you can set classes, Boolean classes or contexts as we're starting to call them, depending on any arbitrary characteristic of the system. So for example, you could say that all the hosts in a particular network are to be considered as test hosts, and others are development hosts, and others are production hosts. And you can, within the policy itself, take different actions or do different things depending on which category you're working with. So moving a system, for example, from testing to production is just a matter of reassigning the class to which that host is considered, and then CFEngine takes care of the rest automatically. And when can we expect to see an addendum to the book, Advanced Policy Writing, Complex Orchestration, etc.? This is an excellent question. I have been collecting topics that I would like to add to the book, and I will be working with O'Reilly to see how we can make these changes happen, either to the book and make changes to the existing book, or maybe even a new book at some point in time. So I think that's it. I'm not seeing any new questions in the list when I refresh. So I think I will stop here. We're almost also to the hour. I would like to thank you again for coming, for attending, and thank you for all the great questions. I really hope that you found some useful information in the webcast. And my contact information is here in the last slide. Feel free to contact me either by email. I'm also usually in the CFEngine forum or on the IRC channel, so I'd be very happy to chat with you about any other topic that you want or any questions that you have, and I really look forward to hearing from you. So thank you again, and have a good afternoon or morning or evening, depending on where you are.